Hi everyone. So let me start. I'm Priyansh Mehta, currently an upcoming software engineer at Flipkart, and I have been a project maintainer at Opia Foundation and in my final year of college. So little bit about myself. From the very start of my college, I have been experimenting and trying out different things and love to play with things and see how they work out. Initially, I tried to learn things through courses and all taking tutorials, but I saw that never worked out for me. So this is how I started my journey. I started contributing to Opia Foundation, my first ever organization. And within 3 months, I was so good in things that within a duration of 5 months, I became the project maintainer itself. So I guess I believe contributing to open source programs is really a great thing, and you get to learn you get to learn everything by experimenting. So coming to the thing, as we all are really short of time today, so this was the project that I did, diving into Zowe App Store and how OSS transformed me. I would really say that open source software has a very big role in how the career played out for me. It helped me in so many things. So to start it out, I assume you guys are all like me, who never knew what Zowe and Open Mainframe is. I'm assuming that. So these are the mainframe systems that you see, very classical, old, modern I won't say, very classical, big metal machines that are used to process lots of data. Okay, they are used to process lots of transactions, ATM transactions, and data processing they are used. So the problem they have is they are running the legacy ZOS on them, and you have to use terminals to actually interact with those. Isn't that very boring? Like today we all are using so many UIs, GUIs that we actually won't be able to use a terminal. So that's why Zowe is this. This is what Zowe did. It provided a complete interface to mainframe, ZOS. Zowe provided a complete interface. Okay, so just a question, you might all be wondering, we have our individual computers, we have our gaming machine, I have a gaming laptop, and why in the world today do we need a mainframe? This was my exact question to my mentor, why do we need a mainframe when we have so good machine? Why is it still needed? So to quickly sum it up, this is the first you saw, that is the mainframe. The sports car is actually our gaming laptop. And this is pickup van is a normal, a personal computer. The difference being a mainframe can actually transform or process a lot of data at a single point of time. It can carry that megabytes, terabytes of data and process it. It has so many cores running in parallel with one another. But on the other hand, our gaming laptops and individual PC, they are serve a single customer. My gaming laptop will only serve me. It can't serve millions of transactions at a time. That is not possible for it. Same with the user laptop. So I guess you guys understood why we still need a mainframe. We have so many transactions, ATM transactions, and everywhere. Data going from here to there, A to B, B to C. So we definitely still need a mainframe. And we don't want to change the existing ZOS there because it is legacy system and it has been tried and tested. So whatever we built a Unix level over it. Okay, so just a quick demo, what we did. I don't have a very clear video with me currently. I tried to find it out. So this is the Zowe, which is communicating with the mainframe. So what we did, okay. The thing is, Zowe is more like a Windows for mainframe. Windows for mainframe, it is an operating system for mainframe. So what I did, there are a lot of applications that you can install on ZOS, but there was no such direct way. How will you install it? You have to write multiple big commands. So what my mentorship project was all about, it was making this app store. Here in this app store, all the applications, plugins are listed. The developer just has to click install, and the following plugin will be installed on the mainframe, the traditional big machine that we all discussed about. So it will automatically get installed. Now, okay, that's cool, yeah, it will get installed. But high-level design, you might be asking, what's the magic running behind this? So to sum that up, let's see. The thing is, this is the high level design. I will try my best to keep it as simple as possible. So the first, you guys can see the virtual desktop, the Zowe desktop. This is all the front end side of the thing. Whenever a user clicks on install, update, or search, what happens? We have a ZSS server, ZSS server, Zowe system server. So what it does, it calls a data service. Okay, so data service is what? Data service is a way, this is a Unix part and this is a ZOS part. Unix and ZOS. Data service is what communicates in between. It communicates between the ZSS and the mainframe system. So I wrote that data service and that needed to be written in Metal C. So what was done? We have these commands. You can see ZWE commands run to install. So whenever a particular call was made, let's say install, ZWE install, application name was run on the ZOS, and the system was actually installed on the ZOS. So to actually brief it up, users calls on the front end side. It triggers the ZSS server. We call the data service. Data service on the mainframe system runs these commands in the terminal. And finally, you get your plugin installed. I guess you guys got a pretty basic idea what it was and how the whole high-level design was all about. Okay, so learnings. To be very true, I believe we all live in a world full of abstraction. I myself have before this used Python, Node for servers and all, and I would say that is world full of abstractions. You have so many things out there which is already done. You just have to run start server and everything is already there. You have a HTTP server, you have a JSON parser, you have a REST API framework. But when it came to C, I got to know even to read a JSON file, you have to somehow parse that in C, and that is the mammoth of the task. That was the hardest for me, and it almost made me, break me down to understand that C. So it was one of the biggest challenges during my mentorship period, but it took me around 1 to 1.5 months, half the period of my mentorship. But when I got to understand how everything was done, coming from an abstracted world of Python, so then things made sense, and I was actually able to write my own HTTP server library, which is used in GZ. And the world of abstraction and coming to C taught me a lot of things. Trust me, it taught me so many things from the bottom, from the scratch level. So definitely C is a thumbs up. Everyone, if they get some experience, they should code in C. I would say after that, you got to learn so many things. So my feature has been not in my mentorship, but after this one, it got completely merged and is live currently. And I'm really happy for that. So yeah, and a big thanks to my mentor, Lenny. He has been like quite very helpful during this whole period of my mentorship. Like he was there and he used to provide me source codes. Like these are the codes you can understand, because when I searched the whole YouTube for C, there was nothing. There was no tutorial explaining you how to write code in C, how to make a server. There was no documentation to write anything in Metal C. So Lenny used to provide me some source codes key. This was how it has been done till now, and this is how you can do. So his guidance has been invaluable. I would say the best mentor I could have got. So big thanks to him. And I won't bore you guys. So that's all from my side. These are the handles, Priyan61, everywhere it is. So thank you, everyone.